All right, folks, it is 10 o'clock. Out of respect for your time, I want to thank you for joining us and welcome to the third installment of the Long Coffee Break series. I'm Matt Bilsma, sales engineer with Long Building Technologies, and I have with me today Chad Hunt from Cambridge Air Solutions. You may be familiar with Cambridge as being a leader in heating, ventilating, high-bay commercial and industrial spaces with direct fired makeup air units. With the recent acquisition of Spec Air, Cambridge has moved from being an H&V manufacturer to an HVAC manufacturer. As building energy codes become more restrictive to energy use and market demands for more comfortable work environments increases, direct and indirect evaporative cooling equipment is worthy of consideration in conditioning air, especially in large volume spaces. Chad, welcome, and please lead us through the discussion on Cambridge's direct and indirect evaporative technology.
Thank you, Matt. Thank you, everybody, for taking some time out this morning to learn a little more about Cambridge and what we've done over the past couple of years. We've been on this mission of creating better work environments for hardworking people. Most people know Cambridge as leaders in heating and ventilating, as Matt alluded to, high-bay spaces. So we're talking about industrial, manufacturing, and light commercial spaces with large infiltration loads, a lot of stratification issues, and a large portion of exhaust air due to the process conditions. So we've been heating and ventilating those spaces successfully for the past 50 years, and we're excited to announce that we've actually listened to our customer base, and what we've been hearing is they're having a lot of issues with cooling those spaces. Cooling industrial spaces is kind of an oxymoron because of all the issues I talked before, but we purchased Spec Air in 2017, and it's allowed us to position a product to create those better working environments for those large industrial spaces.
Yeah, Chad, I think a great example of applying this technology is what Cambridge is doing in your own manufacturing facility. And so if you wouldn't mind, can you just kind of bring us through what you all have done there back in St. Louis?
Yeah. Matt, I think that's a great call out. Thank you for that example. So as we've been in this marketplace for 50 years, and we're listening to a lot of our feedback from our customer base, and we realized that we were experiencing the exact same issues. So you've got those high volume spaces, you've got that huge exhaust load, high infiltration loads, a lot of stratification issues. How can you possibly cool that? So we decided to break it down to its simplest form in high and low cost options and high and low complexity options. And we realized that we were right down here, like most manufacturers, in this low cost, low complexity option. We have a makeup air unit, like most codes require, to temper that outside air in the winter. So we're bringing in 75, mid 70 degree air, and we're running across that 70,000 CFM, which Cambridge has. In 200,000 square feet, we have an exhaust load of 70,000 CFM because of a large paint booth. So in the winter, we're bringing across that air tempered, but in the summer, we're just opening up our dock doors, like most industrial facilities, and we're bringing across 95 degree untempered Midwestern humid air in the summer. And it definitely doesn't create that comfortable working environment. And that's the lowest cost, low solution. Our executive team, like most industrial spaces, actually asked themselves, well, how do we cool this facility? So we went right up here to the highest cost, highest complexity, and that was the DX option. That's 70,000 CFM exhaust load at 200,000 square feet in St. Louis. We realized that it was about $500,000 a year to cool this relatively small industrial space. And that's keeping a very steady temperature and creating that work environment. The purchase of Spec Air allowed Cambridge to look at this mid-cost, mid-complexity. And I first of all want to point out that evaporative technology in industrial space is by no means a competitor to DX. And we'll actually get to that in a little bit. So as we were tempering that outside air in the winter, we asked, why can't we temper that in the summer as well and do it for a cost that allows a US manufacturer to remain competitive? So what Cambridge did is we actually created a two-stage evaporative unit for the Midwest, where we don't get the benefit of a direct evaporative option. And we operate our indirect unit most of the time. And we have our direct component of the two-stage tied to a humidistat. So in the summer, we can actually shut the dock doors, and instead of 95-degree Midwestern air, we can now bring in 74, 76, 72-degree air, depending on if that direct component is running, and really create that better working environment. And the good news is we're doing it about 1/5 of the cost of DX. So instead of $500,000, we're tempering air and creating a better working environment for about $100,000 a year. So we keep seeing this trend, and we're seeing these industrial spaces, and I encourage you guys to reach out to your customer base, because I guarantee that a lot of industrial facilities have no idea how to cool those spaces. Cambridge has had this ESeries for 50 years, and being in the Denver market, you guys get the benefit of direct evaporative. We'll go over that data in just a little bit, but the single most efficient way we can cool those industrial spaces is with this product line. So this is our ESeries, our makeup air unit that goes up to 75,000 CFM, and I can give you a direct fire, direct evaporative option to cool those facilities at about $1 a CFM delivered. Ton of different options. I can actually add a chiller. I can add DX to that ESeries, but direct evaporative is going to be our best option. The second option, being in the Denver market, you guys get a benefit of this product as well. But this is our Cambridge ESeries, which is our direct evaporative only unit. And this goes up to 80,000 CFM. So we talk about evaporative in industrial spaces. We look over the past 20 years, we're realizing that if you had 100,000 CFM need, what most people have done is put 10,000 CFM units, swamp coolers, just kind of scatter them all over the building. We don't see a lot of longevity with that option. So what Cambridge is proposing is, why don't we add 4 25,000 CFM units or 2 50,000 CFM units, and we put an industrial grade product on an industrial application. That's where this ESeries comes into play. So instead of having 10 maintenance points, we can actually reduce that down to 4 or 2, and we can provide that benefit of evaporative cooling with the longevity that's expected with that type of purchase. Our last product line is the one I'm most excited about, and this is our ESC, or Evaporative Semi-Custom Unit. So this is what we're introducing to the Cambridge core markets, and really the Northeast, the Southeast parts of the country, is we're saying that evaporative cooling can work on the East Coast. We're just going to have to use an indirect option where we use that second heat exchange and remove the humidity from the space. And that it's been used for a really long time. Data centers have been using this core technology to cool facilities all over the country for years. We're just saying, let's apply this to these industrial spaces where it's really hard to create that comfortable working environment in the summer. So the ESeries allows us to go direct, indirect, or two-stage, like we've done at our facility in St. Louis, and tied the direct portion to humidistat. We can do an indirect or hot water coil as far as heating, and we're actually adding a direct fired portion to our facility to get that certification as well. And the nice thing about this unit is we've got a lot more options as far as mixing and energy recovery, and a lot of different options as far as mounting and installation.
Yeah, I was going to say, Chad, the ESC model is extremely flexible and configurable. Um, I guess we're seeing here what options we have with this unit. Are we limited to these options?
No, this is the only thing I could fit on one page, Matt. It's a great question. So I'd encourage you to reach out to your long sales engineer and really see if Cambridge can construct this type of unit to fit your application, because we have so many options.
I think that's right, Chad, that this is highly configurable. So we really want to look at the application and construct the equipment for that, correct?
Yeah. It's kind of going back to what we were talking about, that, you know, the Colorado, Utah market, you guys get that benefit of direct evaporative, but like most engineering firms, you're not only doing business in your local market, you're going to get those customers in your St. Louis's, your Detroit's, your Atlanta's. And that's where Cambridge is really introducing this technology. You guys have had the benefit of seeing it for the past 20 years, or really your entire careers.
Mm-hmm.
A lot of engineers in Atlanta haven't ever considered in direct or evaporative technology to cool those industrial facilities. So I encourage you to think about that option as we're seeing these other climate zones struggle. This is a great slide because it kind of shows out how the cooling load we can get from your specific areas. So your Denvers, your Phoenixes, your LAs, your Vegases, you guys can see that you're going to get a ton of effective cooling from direct or indirect or two-stage evaporative. But we look into your Minneapolis, your St. Louis, your Atlantas, we don't get as large a benefit until we add that two-stage or that direct component on a humidistat. And we look in Atlanta with 90-degree temperature, we can actually give a discharge of the low 70s when we engage that direct component of the two-stage unit. We give a discharge of mid 70s when we just use the direct.
Yeah, Chad, I was going to say, looking at that Denver, what's close to a summer design day there, when I'm looking at that two-stage option for us, we're getting an appreciable temperature depression there. With, at a 60-degree wet bulb, we're approaching temperatures that would be similar to DX options.
Yeah, you guys get the benefit of that. And the one thing that we can't kind of go back to is just the core idea that direct evaporative is always tied to the outside air, unlike DX. Mm-hmm. So we're changing the conversation instead of how do we cool these industrial facilities, we're trying to have this discussion is how do you create a better working environment? So ASHRAE in December of 2018, in the ASHRAE Journal, had an article about productivity loss with increased temperatures. And through various resources, Cambridge just kind of put that number right at 77F. So at 77F, we actually lose 1% of production in the manufacturing for every degree over 77 we achieve. So you look at the bin data and everything you're going to have those really hot days. We're moved away from trying to cool the facilities and moved into creating a better working environment through evaporative technology, lowering that operating cost, and really allowing us to achieve that. Just a quick recap. You guys in the Denver market, you're going to get the ability to use this ESeries. So that's direct fire, direct evaporative. Cambridge is building these units about 8 weeks. So it's extremely cost-effective way. If you're looking to retrofit or just add an evaporative option, we have this direct evap only, the industrial grade ESeries up to 80,000 CFM. This ESC, again, engage your long representative. We have a ton of options here. This is our semi-custom unit. We're building these in about 12 weeks. But we have your direct, indirect, or two-stage option on this.
All right. Thank you, Chad. And thank you all for taking time out of your day to join us. If you have any general or specific application questions regarding Cambridge Evaporative Technology, please reach out to your long sales engineer. I hope everyone has a happy and safe 4th of July, and God bless America.
Thanks, guys.